Part A asked me to find the equation of my tangent line when x equals to -1. So to find the equation of your tangent line, you need two things. You need to find the derivative, and you need to find your slope. So first thing we're going to do is find my derivative. So my derivative is going to be 4x cubed plus 12x squared. I'm not going to set it equal to 0 because you only do that to find your critical points. So what I'm going to do is I'm going to go ahead and substitute -1 because I'm trying to find the slope at -1. So this is going to be -4 plus 12, which is going to give me 8. So this is my slope of my tangent line when x equals to -1. So the second thing I need to do is I need to find a coordinate. So I need to find my y value. So I'm going to substitute the x into my original equation to find my y value. So I'm going to have 1 minus 4, which is -3. So now I have a point. So I have a point and a slope. So I'm going to write this in point-slope form. And I'm going to go ahead and keep it in point-slope form. So here's my equation of my tangent line. Part B asked me to find the coordinates, so that's an x and y, of the minimum value. So to find the minimum value is I need to have the derivative set it equal to 0 or where the derivative does not exist. Those are my critical points. So those are the two things that I need to find. So in part A, I already found what my derivative is. So I'm just going to go ahead and set that equal to 0 and solve for x. So I'm going to factor out a 4x squared. So I'm going to have x is equal to 0 and x is equal to -3. So these are my critical points. There's no place where the derivative does not exist. So I'm just going to check -3 and 0. And I'm checking the sign of my derivative because I want to see where my derivative slopes are positive and where they're negative. So to the left of -3, I'm going to check -4. So at -4, the 4x squared is always going to be positive no matter what number I put. So I'm just going to check the x plus 3. So -4 plus 3 is going to give me a negative. From -3 to 0, I'm just going to check -1. So again, this is always positive. -1 plus 3 is the positive. And then to the right of 0, I'm going to check 1. So 1 plus 3 is positive. So I have a minimum, no max. So my minimum value occurs when x is equal to -3. So now I need to find the actual minimum value. So my minimum value is going to be, I'm going to go ahead and substitute -3 into my original equation to find my height, my y value. So this is going to give me -27. So the coordinate of my minimum is going to be -3, -27. Okay, part C asks for the points of inflection. So to find the points of inflection, I'm going to find the second derivative and set it equal to 0. So my second derivative is going to be 12x squared plus 24x. And I'm going to go ahead and set that equal to 0. So I'm going to factor out a 12x. So I'm going to have x is equal to 0 and x is equal to negative 1. So those are possible points of inflection. So I need to check the sign of the second derivative to see whether I'm concave up or concave down. So to the left of negative 1, I'm going to check negative 2. So this is going to be a negative. And this is also going to be a negative. So a negative times a negative makes a positive. So now I'm going to check between negative 1 and 0. So between negative 1 and 0, I'm going to check negative 0.5. So this is negative. 0.5 plus 1 is positive. So negative times a positive is a negative. So now I'm going to check to the right of 0, which is 2. So this is positive. 2 plus 1 is 3, which is positive. So that's going to give me positive. So I actually have 2 points of inflection. I have when x equals negative 1 and when x equals to 0. So to find my y values, I'm going to substitute that into my original equation. So I'm going to have 1 minus 4, which is negative 3. So let me erase this. So one coordinate is going to be negative 1, negative 3. And the other one, when x is equal to 0, is going to be 0. So my second point of inflection is going to occur at 0, 0.